Hi, so welcome to this week's session where we are discussing hypothesis testing. So, with hypothesis testing, we're going to learn similar basic things that we have been learning from the previous sessions, like things that we learned in confidence interval, things that we learned in sampling distribution, in the normal distribution, in the discrete probability. It's a build-up. You will see how all the study units are linked together. And the same knowledge that you have learned, you need to carry it through up to now. We are left with two sessions uh, for July. Actually, we are left with two sessions that I'm offering you. So we're going to do correlation next week and the regression, and then on Monday, and then on Saturday, we're going to do chi-squared, and then we are done with all your study units for your module. And my job is done with you guys. And I would like to also say thank you for those who always attend the session and be part of this statistics literacy sessions that we always offer. I really appreciate you being here with us. Okay, so by the end of the session today, you're going to learn the basic concepts when it comes to hypothesis testing. What is it that you need to know about hypothesis testing? You're going to learn how to make decisions using your hypothesis testing for the population mean, when the population standard deviation is known and when it is unknown. You are also going to learn how to use hypothesis testing for the proportion to make a decision. Okay, so in terms of hypothesis testing, we need to also remember it is part of one of the branches of statistics. In the beginning, when we started, we said there are two branches of statistics. There is the descriptive statistics, and there also is a inferential statistics. So where hypothesis testing is, it is part of that inferential statistics. So hypothesis testing is an inferential procedure that uses the sample data to evaluate the credibility of a hypothesis about the population. When we test the hypothesis testing, we are claiming, or we are trying to claim or create a claim about the value of your population parameter using the sample statistic. And here we're trying to also form a claim that will help us make the decision around the entire population. That is why inferential statistics is about you inferring your decisions from your sample statistics to your population. So that is what hypothesis testing is all about. It is what the researcher claims or what the researcher wants to prove. So we are going to learn, like we did with confidence interval, when you do hypothesis testing, you need to ask yourself, if you're doing hypothesis testing for the mean, you need to ask yourself, have they given me the population standard deviation? If not, have they given me the sample standard deviation? Because the two uses two different methods in terms of how you're going to make a decision and how you're going to find the region of rejection. For the proportion, if you are not given the sample proportion, they will give you observation satisfying that sample proportion, and you can calculate by using the P, which is your sample proportion. P is equals to X divided by N formula to find your sample proportion. Always remember, it goes back to everything we've learned in sampling distribution and also in confidence intervals. So when we're trying to do a hypothesis testing, therefore it means we're saying two things. It's like when you say there is a yes and a no answer to a question. That's what hypothesis testing is. There is always a complement of the other. Some statements are true, some statements are not true. So that's what we're going to be doing. So we are going to be stating a claim or an assertion that needs to be tested or proved by means of stating that in your null hypothesis. There will be two statements that you create when you do hypothesis testing. One is the null hypothesis and the other one is the alternative. When you state the null hypothesis, it is what the researcher wants to prove, always. We always going to be using the population parameters. So now you need to be very careful and remember this all the time. When you state your null hypothesis, you always need to use the population parameters. And what are those population parameters? It's your mu and your pi for the proportion. Remember, parameters, we use the Greek letters. We don't use the sample statistic, which are your Roman letters, like your normal letters, like your X bar, your S, your P. We use the Greek letters. We begin the assumption that the null hypothesis is true, which is similar to the notion of you are innocent until you are proven guilty. Always, your null hypothesis has an equal sign. This is another thing that you need to always remember. Sometimes they might use the less than or equal or greater than or equal. But most of the times, your null hypothesis, because it always has an equal sign, they will use an equal sign. Regardless of whether the researcher wants to prove that it's greater than or equal or less than or equal, they might still use an equal sign in your null hypothesis statement. But remember, always, what the researcher wants to prove always goes into your null hypothesis. Therefore, it means if the researcher wants to prove that the mean is greater than or equal, then it's going to go on to the null hypothesis. But if the researcher wants to prove that the mean is less than, then it will go into the alternative and we're going to create a false null hypothesis, and we're going to get to some of this. We will expand them further. When we get to the final decision, when we're making our conclusion and making our decision at the end, we make it in relation to the null hypothesis. So our null hypothesis can either be rejected or we do not reject the null hypothesis. The alternative, which is the complement of a null hypothesis, before we move to the null hypothesis, you will denote the following. Remember always, your null hypothesis has a subscript 0. Your alternative hypothesis, we write it with a subscript A or subscript 1 or subscript C, depending on how they refer to it. But it will always have a 1 or a C or an A as an alternative. The alternative hypothesis is the opposite of your null hypothesis. So if in your null hypothesis you wanted to prove that the mean is equal, then your alternative will say the mean is not equal. If you wanted to prove that it is less than or equal, the alternative of less than or equal is the complement of it will be it is greater than. If it was greater than or equal, the alternative will be it is less than. Always remember, in your alternative, there is no an equal sign. So therefore, there are 3 statements for the alternative that can exist. It will be not equal, less than, or greater than. Whereas in your null hypothesis, you have equal, less than or equal, or greater than or equal. Because in your alternative, there are no equal signs. There is no any equality sign on the statement. We do not even bother to reject or not reject the null hypothesis because we don't have to prove anything about the alternative. We use the alternative, however, to help us with making the decision. And you will notice the following. The statement we put in our alternative hypothesis, this is something that you always need to remember. The statement you put on your alternative hypothesis will help you make the decision. So these 3 signs are very important because they will help you get to the final stages of your hypothesis where you make your decision. They will help you to find how your region of rejection will look like, whether it is on the left or on the right, or it's both. And it will also help you to go find the critical values, because when you go find those critical values, you need to know whether you're going to divide your level of significance by 2 or you're going to use just that. And we're going to learn about those things just now. When we do a hypothesis testing, sometimes we might create some errors. And this happens when, one, I've already said it in the beginning, I said, the null hypothesis is what the statement of the researcher or what the researcher wants to prove. If the researcher wants to prove that the mean is less than or equal, we're going to put it in your null hypothesis. But if the researcher wants to prove that the mean is less than, we cannot put that statement, we cannot put that claim in your null hypothesis. We're going to put it in the alternative, and we're going to create a false null hypothesis because it will force us to put an equality sign to the claim, whereas the researcher didn't put the equality sign to that claim. So we are creating a false hypothesis. Now, when you have those kind of situations, then you are bound to make some errors. Sometimes there are errors that we create, even with the normal, how we state our null hypothesis and our alternative and how we do the decision, we get to create an error. But you need to know these errors. So type 1 error, it is an error where we reject the true null hypothesis. So the true null hypothesis in this instance would be the researcher wants to prove that the mean is less than 30, less than or equals to 30. The mean is less than or equals to 30. That is a true null hypothesis. If we reject that, when we get to the decision and we reject the null hypothesis, we are committing what we call a type 1 error. And this is the error that we mostly going to commit every time we do the null hypothesis. We consider this as a serious type of error, and this is the and this error, it's the probability of type 1 error. It's given by the level of significance, or alpha, which we also call it the level of significance, or we call it the alpha value. And this alpha value, usually it is set at the beginning by the researcher. So we will set it at the beginning. We will say it is 5%, or we will say it's 0.05, or we will say it's 10%, or we will say it is a 99% confidence. And then we can calculate our alpha. Remember how we do it in the confidence levels. Then we also have a type 2 error, and the type 2 error is when we fail to reject a false null hypothesis. And remember, when we said a false null hypothesis would be when the researcher wanted to prove that the mean is less than 30. We create a false hypothesis that will say the mean is greater than or equals to 30, because the researcher wants to prove that it's less than, and the less than goes into the alternative, but our null hypothesis stays as less than or equal because it's a complement of a less than. A greater than or equal is a complement of a less than. So now we have created a false, and we can also create a greater than or equal, or we can just say it's equal. So we have created a false null hypothesis. If we do not reject that null hypothesis, we are committing what we call a type 2 error. And a type 2 error is denoted by beta, or that letter B. Okay. Always remember, when we do hypothesis testing, especially when we put the sign in the alternative, remember the symbol. Symbols, very important. Remember the meaning. How they ask you a question, They can put it in a word phrase. Remember those word phrases. What exactly mean? What fewer than mean? What below mean? What up to mean? What more than mean? What above, exceeds, in excess, at most, no more than, does not exceed, at least, no less than. You need to remember this. It's very important, because if you get the signs wrong, and you interpret them wrong in terms of the word to the sign, your answers will be incorrect as well. So this is very important. And if you want, you can also take a picture, so that when we do the activities and we look at the exercises, you already have something where you can reference. Okay, there are 6 steps of hypothesis that you need to always remember when you do hypothesis testing. And we're going to go through each one of them when we do the examples. Step number 1 is to state your null hypothesis and your alternative hypothesis. Step number 2 is to choose the level of significance, or your alpha, and your standard deviations, and your sample size. Step number 3 is to determine the appropriate test. Here you just state what type of a test you are doing. Is it a t-test or a z-test? Step number 4, depending on what type of a test you are doing, you're going to determine where your region of rejections are by using the critical values. This is very, very important, especially once you have stated your null hypothesis and alternative hypothesis. It's very important. You look at your alternative hypothesis and you say, am I doing a one-tailed test or a two-tailed test? And this is very important when we do some, I will expand on this further just now. Also, when you look at your step number 2, when you determine what you are given, whether you're given a population mean or you're given a sample or a proportion, you need to be able to know what type of a test statistic you're going to be doing. So because if my population standard deviation is unknown, then I'm doing a t-test. If it's known, I'm doing a z-test. Unknown, t. Z-test is when the population is known. And all this helps when you go and do your region of rejection, which is your critical value. When you get to the critical value, you already know. If I'm doing a z-test, then I need to ask myself 2 things. Am I doing a one-tail? Will I find 2 regions of rejection? Or am I finding 1 region of rejection? So is it one-tail or two-tailed? And that depends. How you're going to find your region of rejection also. For when it's one-sided, we just use alpha. When it's two-sided, we divide alpha by 2. You always need to remember those things, and we're going to discuss them just now. Once you have found your region of rejections, then you're going to calculate your test statistic, whether it's a z-test or t-test, you calculate that test statistic. Once you have the value of your t-test and your z-test, then you make your decision and you use the critical value. That is, if we're making decisions based on the critical value, then you look at the region of rejection and you look at the test statistic and say, does it fall within the region of rejection, or does it fall in the do not reject region of the region? And then you make your decision whether you are going to reject the null hypothesis or not. So now let's look at this. So let's assume that our population standard deviation is known. So when the population standard deviation is known, then we're going to run through step 1 up until step 6 to see how we place it. So the first step is to state the null hypothesis and the alternative, depending on what the researcher wants to prove. Then you state your null hypothesis and your alternative. If in my alternative, then it says it's less than. Remember, look at the 2 statements that we have there. So we state that the null hypothesis is the mean is greater than or equals to 3. In the alternative, it will state the opposite, which will say the mean is less than 3. Otherwise, we can state it this way. It's still applicable. The mean is equals to 3. The alternative will say the mean is less than 3. And this, because it says less than, we call this a one-tail test because it's pointing to only one side of the table or one side of the test. It is on the lower side because it's less than, it is on the negative side, or it is on the lower side. It's pointing to the lower side of the Z or whichever test you are doing. Okay, when we have a greater than in your alternative, we also say it is a one tail because it's pointing to the greater than side, the greater side of a test. So the null hypothesis will state that it is less than or equal, or we can just say it is equal, and the alternative will say it is greater than. You will notice that in the alternative, there is no equal sign, right? When we have a two-tailed test, the mean will be equal. The alternative, the null hypothesis will say the mean is equal. The alternative will say the mean is not equal. And that is a two-tailed test. It's very important to remember all that. One-tailed test, two-tailed test. So we state what we are given in the question. So because our population standard deviation is known, we know what the population standard deviation is, our sample size is, and our level of significance is, because they would have given all those things to you. Then we can state what the test is. Because the population standard deviation is known, our test will be Z test. To determine the critical value, so we start with the one-tail test, especially when it is on the lower side or on the greater side. It's one-tail test. We're going to find the critical value, which is our Z value, by using alpha value. So instead of dividing alpha by 2, like we did with the confidence interval, because we had two regions, the lower side and the upper side. Here we've got only one region. We only use alpha. So what we do, we take that probability value of alpha, we go to the Z table, we go look for, if it's 5%, we go look for 0.00. If it's 5%, we go look for 0.05. Inside the table, we move outside of the table, we go to the left of the table, we get a digit before comma and a digit after comma, and we go up the table, we go get the last digit on at the top, and that will give us our critical value. If it is on one side, right? So actually on this side, we should be putting a negative in front because it is on the lower side. It is on the lower side. So it will be negative Z alpha, and then on the positive side, it will be Z of alpha. That's what we're going to be getting. So when you go to the table, you find the value. If it's 1.96, if the sign here is less than, we put negative in front. If it's the sign is greater than, we put a positive, or you can just leave it as positive. If it's a two-tail, we're going to take alpha, we're going to divide it by 2, and therefore it means we're going to find two regions of rejection. We're going to find Z alpha over 2 and Z alpha over 2. We're going to find two critical values, like we did with the confidence interval, where we find two regions of rejection, or two regions. So we're also going to find two regions of rejections on this. The next step is to calculate the test statistic. Because we're doing a Z test statistic, we use the sampling distribution Z test statistic, which is the mean, the sample mean minus the population mean divided by the standard error, or divide by the population standard deviation divided by the square root of n. Once we have calculated the critical value, we have got the region of rejection, then we can go and make a decision. I usually like to draw up the picture like this because it makes me, or it helps me visualize what is it that I'm going to be doing in terms of the rule or the decision. The rule says if your Z test statistic is less than your critical value or your region of rejection, you're going to reject the null hypothesis. So therefore it says, if my region of rejection is at this point in the negative side and my test statistics falls in the shaded area, I'm going to reject the null hypothesis. But if it falls on the right side of the critical value, I do not reject the null hypothesis. So that is one. And remember, it's on the negative side. On the positive side, we do the same. It says, if your test statistics is greater than your region of rejection or your critical value, you reject the null hypothesis. Otherwise, if it's less than, you do not. So if it falls in the shaded area, we reject the null hypothesis. If it falls in the white area, we do not reject the null hypothesis. When it's a two-tailed test, when there are two regions of rejection, because we found that if it was alpha was 0,05, we divide that 0,05 by 2, which will give us 0,025. We go and find the region of rejection on that, and we find that the critical value is 1,96. Then we're going to put minus 1,96 on one side and positive 1,96 on the other side, because we're going to create two regions of rejection, the lower side and the upper side. So the rule says, if your test statistic, that one value, the test statistic, if it falls either on the left-hand side, if it's greater than your region of rejection, if it's less than the region of rejection on your left, you reject. If it's greater than the region of rejection on the right, you reject the null hypothesis. But if it falls inside the white area, we do not reject. So if it's less than, if it's greater than, if it's greater than negative critical value, you do not reject. If it's less than the positive critical value, you do not reject. So those are the rules that you're going to use to apply to answer the question. So let's look at an example. For this example 1, for a sample of 35 items from a population for which the population standard deviation is sigma is equals to 20.5, the sample mean is x bar is equals to 458, sorry, at 0,05 level of significance, the tutor wants to test that the null hypothesis is the mean is equals to 450 against the alternative that states that the mean is not equals to 450. Which one of the following statement is incorrect? I'm going to disregard all these options and I'm going to do the null hypothesis statement. Statement 1 up until statement number 6. So statement number 1, already state your null hypothesis and alternative. They've already did that for me. So I'm going to just say, in terms of statement number 1, what type of a test am I doing? I'm doing a two-tail test because it's going to help me answer the following question. Step number 2, it says state what you are given. I'm giving my sample size of 35. I'm giving the population standard deviation of 20.5. I'm giving the alpha value of 0,05 based on the statement that I have, because my alpha value is the level of significance. Statement number 3, it says, what type of a test am I doing? My population standard deviation is known. So sigma is known. Therefore, I'm doing a Z test statistic. Step number 4, it said, find the region of rejection. I'm doing a two-tailed test. Therefore, it means I have two regions of rejection. Z alpha divided by 2, which will be Z of 0,05 divided by 2, which is Z of 0,025. And I know this because when I go to the table and I locate the values on the table, I will find 0,0250 in the table. And when I go out, I'll find 1,9 on this side. And when I go out, I'll find 0,06. And that will be my critical value, 1,96. Step number 5, it says, calculate the test statistic. I'm doing a Z, so therefore my Z will be the sample mean minus the population mean divided by the standard error. And here, my sample mean, it's given in the question somewhere. There, the mean is 458, 458. My population mean is given in the statement because in the null hypothesis, we use the population parameter. So it's 450 divided by my standard deviation of 20.5 divided by my square root of n is 35. And I'm going to use my Casio because I want to save time. Let me just go to my calculator and do the calculation. So I'm going to use the fraction calculations. So it's 458 minus 450, down arrow, again another fraction, 20.5, down arrow, square root of 35, and out, out, and answer. And the answer is 2.31. My Z value is 2.31, and that is my Z value. At this point, please ignore the p-value for now on that. I will get to it just now. 6, it says I must make a decision. So let's make a decision. I'm doing a two-tailed test that tells me, therefore it means I've got 2 regions of rejection. So I'm going to draw up my rejection areas. And this will be the positive 1,96 and this will be the negative 1,96 because those are my region of rejection. So this creates a region of rejection. So those are my region of rejection. Then I can make a decision. Where is my 2,31? So 2,31 falls somewhere on here, right? It falls on the 2,31 falls in the reject null hypothesis. Remember, if it falls there, we reject the null hypothesis. Therefore, we make our conclusion since the Z stat of 2,31 is greater than the Z alpha divided by 2 of 1,96, we reject the null hypothesis at alpha of equals to at alpha of 0,05 and conclude that the population mean is equals to 450. So you conclude with that and conclude that the mean is equals to 450. And that's how you make a decision. So let's see if we can answer this question right here. I haven't touched the p-value because I want us to I'm going to introduce it later on so that we can answer the ones that we have in front of us. So number 1 says a two-tailed test statistic is appropriate to this situation. That's correct because that's what we said, the two-tailed test statistic. The critical value is 1,96. We did calculate it on that. It is correct, it's 1,96. The test statistic is 2,31. The test statistic is 2,31. We calculated that and we found that it's that. I'm going to jump the p-value and I'm going to introduce it later on. We can always come back to this example if we want to determine that. Statement number 5 says H naught is rejected at the level of significance of da 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 da. So we know that we reject the null hypothesis. Therefore, we say that is correct. Therefore, it means the incorrect statement here would have been that one. But I'm gonna get back to the p-value just now. But yeah, I just wanted to demonstrate to you that you need to know all the 6 steps of hypothesis in order for you to be able to answer any question if you get them in the exam, because every statement or every option in the exam question might be, or in your assignment, might be one of the hypothesis testing. As you can see, the only 2 statements that I don't have on this question are those 2. But those 2 are very important because they help me find the other questions or other to answer other activities. So it's very important to know all 6 steps of hypothesis and how they all work together. Okay. So in this instance, we're going to assume that the incorrect statement is option number 4, but we can always come back to this question when we get to the p-value. So what happens when the population standard deviation is unknown, sorry. When it is unknown, then the same thing. We state the null hypothesis and the alternative hypothesis like we did for a one-tailed test, a two-tailed test, for the lower and the upper one-tailed test and the two-tailed test. We state what we are given. Now, remember, because the population standard deviation is unknown, they would give you the sample standard deviation, which is an S. So we now, from here, we can determine that our population standard deviation is unknown. And when it is unknown, then we're going to be using a t-test statistic. We introduced a t-table when we did the when we did the confidence intervals, right? So we used the test statistic. Finding the critical value, we are going to find it on the critical values of t table, but we use the probability, which is the alpha value or the level of significance, and the degrees of freedom. And our degrees of freedom is n minus 1. So the degrees of freedom is n minus 1, which is the sample size minus 1. For a one-tailed test, we do use only alpha. For a two-tailed test, we're going to divide alpha by 2 and go find the critical value. Then we calculate the test statistic. Remember, for t, because we have the sample standard deviation, then it is the sample mean minus the population mean divided by the standard error, which uses the sample standard deviation divided by the square root of n. And once we have calculated the test statistic, then we can go and make a decision. We're going to find the region of rejection for every one tail on the lower side, on the upper side. So on the lower side, the t will be negative, and on the positive side, it will be positive. And on the other side also, we go find the 2 critical values, the critical values of t, and so on. So let's look at an example of how we apply this. So a study was done on the daily balances. Assume that it's normally distributed. So the cash balances of a bank to an, oh wait, sorry, let me read this correctly now. A study was done on the daily cash balances of a bank to investigate the hypothesis that the average cash balance did not exceed 25,000. The sample of 100 days yielded a mean of 24,920 and the standard deviation of 300. A hypothesis test with alpha of 0.05 was done. The critical value in this case is, no, not that statement. Not that one. Which one of the following statement is incorrect? So we need to find which of the statements is incorrect on this one. So what is it? We need to first state our null hypothesis and our alternative hypothesis. Do not exceed. So what did we learn? What does do not exceed mean? Do not exceed means less than or equal. So our null hypothesis will state that the mean is 25,000. The alternative will state that the mean is less than, because here we have less than. So less than or equal, we're going to change the sign because the alternative hypothesis cannot have an equal sign to it, since this is do not exceed. Or this one, sorry, my bad. We can also state it as the mean is less than or equals to 25,000. And this will be the opposite of that, will be greater than, which is it exceeds 25,000. Step number 2, state whatever is given. What is our alpha? They told us that alpha is 0.05, and our sample size, they told us that it's 100. And we can ask ourselves, what is it that they have given us? They say the sample of 100 yielded a mean. So because this is from the sample, the mean X bar, the standard deviation from the sample is S. So we are given S of 300. Step number 3, what type of a test are we doing? Oh, no, let me write step number 3 here. Step number 3, what type of a test are we doing? Because our population standard deviation, sigma, is unknown, then we're using a t test. Step number 4, we need to find the critical value t, looking at our alternative hypothesis. It says greater than, so therefore it means we are doing a one-tail test. This is a one-tail test. And since it's a one-tail test, then we're going to find our T alpha and the degrees of freedom. And our T is 0.05. And our degrees of freedom is 100. 100 minus 1, which is 99. Then we need to go to the critical values of T table. Remember, on the critical T table, you go to 0.05, which is the third column, and you go to 99. 1, 2, 3, which is 1.6604. 1.6604. Step number 5, we need to calculate our T-stat, which is the sample mean minus the population mean divided by your sample standard deviation divided by the square root of n. Our sample mean is 24,920 minus 25,000 divide by the standard deviation of 300 divided by the square root of 100. Go to your calculator and calculate. So 24,950 or 920 minus 25,000 divided by 300 divided by the square root of 100. And the answer we get is minus 2,67. Step number 6, we need to make a decision. Because it is one tail test on the upper side greater than, then our region of rejection will be on this side. And our critical value, we did find it. It is, I'm going to keep only 2 decimals. It's 1,66. Where is our test statistic? It falls somewhere on this side. Because right here in the middle, we must remember that this is 0. So it will fall somewhere in the negative side. And therefore, the reason we're going to conclude by saying we do or not reject the null hypothesis since I'm writing it in a different manner now. Since there's not the Z, but the test statistic set of minus 2,67 is less than the T alpha and degrees of freedom of 1,666. And we can conclude that there is enough evidence to, or whatever the thing, we can conclude that there is sufficient evidence to reject the null hypothesis or something like that. Okay, so let's see if we are able to answer the question as given. We're looking for the incorrect statement. The alternative hypothesis will state that the mean is less than 250. We know that that is not, because it said it did not exceed. So therefore, they did not exceed. It's less than or equal because it doesn't exceed 25,000. So it will be either 25,000 or below. Then the alternative has to be greater than. So because of that, that will be the incorrect one. The test statistic, we calculated it. It is correct. It was minus 266. We use the t-test. Yes, the t-table. We use the t-table because the population standard deviation is unknown. That's correct. There is enough evidence to support the statement at 5% level of significance. Yes, we were able to use the information given to make a decision. We fail to reject the null hypothesis. Yes, we do not reject the null hypothesis. And that's how you conclude. So you can see that I've used step number 1, step number 3, step number 1, step number 3, step number 5, and step number 6. So almost all the steps have been used. And in order for us to get to step number 6, we had to use step number 4 because we needed to find the critical value. So you can see that all the 6 steps applicable in answering any questions. Okay, moving on, unless if you have a question, and I see that we are over time, but because we used up the 10 minutes, just allow me that another 15 more minutes to conclude this. So when we look at the proportion, similar. So with the proportion, you state your null hypothesis, and we use the population parameter, and you state what you are given. So in terms of this, you are not given that, you will be given P, and if you are not given P, you will calculate P. I will fix. If you are not given P, you are able to calculate the sample proportion. When we're looking at the proportion, we always use the Z test. So you're going to find the critical value using your Z value. For one tail, it will just Z alpha. For two tail, it will be Z alpha divided by 2. You're going to be calculating the test statistic by using the sampling distribution Z value, which is your sample mean, your sample proportion minus the population proportion divided by the standard error, which is the square root of your population proportion times 1 minus the population proportion divided by n. Remember, this is similar to that formula we used in the sampling distribution. To make a decision, similar. For a one-tail test in the lower side, we're going to use the negative Z alpha. In the positive side, we're going to create the region of rejection using Z alpha positive. And if it's a two-tail, we're going to have two regions of rejection. How we test the claim. A marketing company claims that it receives 8% of the responses from its mailing. To test this claim, a random sample of 500 surveyed with 25 responses. Test at alpha of 0.05. So now, in order for us to test this hypothesis, we're going to state our null hypothesis and alternative. Null hypothesis, the mean is, the proportion is 0.08. Remember, they said it is 8%. So 8% divided by 100. Proportion, always remember, it's either going to be given to you in a percentage or in a decimal format. So always remember those things. So the mean, the null hypothesis, the proportion is equals to 0.08. The alternative, the proportion is not equals to 0.08. State what you were given. We were given the alpha value of 0.05. We were given the sample size of 500. We were also given the sample proportion, but we were not given the sample proportion. We were given the X value, which is 25, divided by this sample size will be 25 divided by 500, gives us 0.05. So this we found by using 25 divided by 500 to find 0.05. We found the critical value because we're doing a two-tail test, alpha divided by 2, which is 0.025. We know that it is 1.96. We find two regions of rejections. So on the negative side and on the positive side, we went on and we calculated the Z-test statistic, and we found that it is negative 2.47. And from there, it falls in their rejection area on the negative side, because negative 247 is less than 1.96, because on the negative side, the bigger the value of a negative, it's less than the smaller the value of a negative. So it falls in this rejection area, and therefore we're going to reject the null hypothesis at alpha of 0.05 and conclude that there is sufficient evidence to reject the company's claim of 8% response rate at alpha 0.05. That is when we have the proportion. Now let's look at how we use the same information, especially for this to make a decision using the p-value. I said when we were doing the first example, we will get to the p-value. So when we use the p-value approach, when we get to the conclusion or the decision, we compare the value of your p-value and your value of your alpha. If your p-value is less than the level of significance or alpha, we reject the null hypothesis. And if it's greater than or equals to alpha, we do not. And this is only applicable when we do a Z-test. So it means Z-test for the mean and also for the proportion. Remember, if the p-value is low, H0 must go. So when we test the hypothesis, either for the mean or the proportion, using the p-value to make a decision, not the critical value, but the p-value, the same statements hold. We state the null hypothesis and alternative. We state what we are given. We state that the test statistic is the Z test statistic. Then we calculate the test statistic, whether we're doing it for the mean or the proportion, and then we make a decision. Now, when making a decision, it's very important to remember the following. Remember, the decision rule says if the p-value is less than the level of significance, we reject the null hypothesis. Now, the p-value, we're going to find it by using the Z test statistic. So the value that we get after we calculate the test statistic, that is what is called the p-value on the table. So that is the probability that we're going to find on the table. So remember, we're going to find the Z value, which might say 1,96. If that is the Z value that we find, we go onto the table, we get the probability on that table, right? So that is that. Always remember, we still apply the same concept. How do we find the probability of Z less than a value? It is the value on the table. That is what we're going to be finding. So at this point, our PZ, so if I write this, the probability of Z less than a value, which is also called the p-value, it is the value that we find on the table. So we're going to use the same logic. That will be the table value. When it is on the greater than sign, then we're going to say the value on the table will be 1 minus the Z value. So remember this, when the Z is greater than a value, we're going to say 1 minus the table value, because we know that the Z table contains the less than values. So if we're going to find the p-value, we're going to say 1 minus that value from the table. So it's the same concept, right? So you're going to find your p-value by saying 1 minus the value you find on the table for a greater than. If it is a two-tail, then it works different. If the Z value is negative, right? If the Z value is negative, so it means if here, the answer here is negative value, then we're going to say the p-value will be 2 times the value you find on the table. You're going to multiply the value you find on the table by 2, or you can add them together. If it's positive, you're going to say 2 times 1 minus the value you find on the table. This is very important for you to remember always on the hypothesis testing. So let's look at an example based on the previous exercise that we did on here. We stated the null hypothesis, we did all this, and we found that our Z value is negative 2,47, right? So that's what we found. We found that our Z was negative 2,47. Remember now, I said if it's negative, there are two things. If your Z value is negative, then we're going to say 2 times the value you find on the table, right? So we go to the table, we go to the Z table, we look for negative 2,4, and we look for 0,07 at the top. That value that we find here, we're going to add it twice, or we're going to multiply it twice. So that value is 0,0068. So it will be 2 times 0,0068, or you can add them together. And that will give you the p-value of 0,0136. And we're going to reject the null hypothesis, because you're going to say your p-value is less than your level of significance of 0,05. And that's how you find the answers. And that concludes today's session. I wanted to do this exercise, but you can do it on your own, which is another exercise that looks at the proportion. And I had some activities as well. So If you want, you can take a picture of each of these exercises and do them on your own. And when you have time, you can always ask questions on the WhatsApp group as well. Yes, exercise number 2. On this one, you also need to just make sure that you select the correct rejection statement. Exercise 3. And exercise 4. So on exercise 4, you can see they're asking you if they have calculated the test statistics. So they would have calculated your Z value and they found that it is negative 2.74. But they also tell you that this is a one-sided test. So you also need to remember those things. One-sided test. What does that mean? It means you have, and they also tell you that it is on the lower side. So it means it's on this side. That's where your region of rejection would be, right? So if it's on this side, therefore it means it's on the less than. So if this is your test statistic, suppose that the population standard deviation is known, what will be the p-value? So you always need to remember that. So because it's on this side, so your p-value will just be the table value. Right. Next, on this one, it says you have a two-sided test. So you can also look at the two-sided test. And they say if this is the test statistic on the two-sided test, what will be the p-value? Remember, then your p-value, this is positive. It will be 2 times 1 minus the table value. That's what you need to be calculating. So I'm already giving you answers to the questions. Also on this one, this one they're asking you to find the critical value of T. So on this one, you will find T alpha and the degrees of freedom. But you also need to be very careful. It says two-sided. So you will have to divide your alpha by 2 and your degrees of freedom is n minus 1. And then you go to the table and look for alpha value at the top and you look for the degrees of freedom on the side where they both meet. That would be your critical value. And on this one, they want you to see if you are able to understand the hypothesis. And here, because it's only the conclusion, so it means you need to have already did step number 1 up until step number 5 to get to step number 6 to answer this. And bear in mind, this statement tells you everything you need because they gave you the standard deviation. You need to read the statement correctly to identify whether that standard deviation is it the sample standard deviation or the population standard deviation. And because it reads from the same sentence, you need to be able to identify it with ease. And that concludes our session with my last question, which is this one, which is also straightforward. It's for the proportion. And I'm not even going to get into this for today. Are there any questions? And I would just like to, before any other question, to send my regards and appreciation to all our loyalty members. Are there any questions? Because we are way out of time. So in the absence of questions, then thank you for being part of the session today. See you on Monday. Have a lovely weekend. Bye.
Thank you, Lizzie.
Yes,
Bye.
Lizzie.
Bye,
Bye.
everyone.
Bye.